As a quick reminder, when we used direct address tables, we did the following. So we have a table here. It's going to have some a key and some data. And suppose we have Joe, and his student ID is, say, 587. In that case, then this is going to map directly to index 587, and Joe will be there. Okay, but hash tables are a little different in that we still have an array. It's probably going to be quite a bit smaller, and we will, here are the indices on the left. We have Joe, and his student ID is 587, but before we put it in the hash table, we feed it through a hash function, and then it's going to map to something probably different, say index 18, for example, and that's where Joe goes. And the topic of this video is, what about that hash function? What does it do, and what do we want it to do? First of all, what makes a good hash function? We want uniform distribution. Uniform distribution, what does that mean? Let's say we have a hash table here, and we have a hash function, and we get some inputs, and the first one goes here, and the second one goes here, and the third one goes here, and the fourth one goes here, and the fifth one goes here, and the sixth one goes here, and then the seventh one goes there, and then we keep going here. This is a bad hash function. All of our values are concentrated in one area of the table, and we're going to get a lot of collisions. A good hash function is going to look something like this. We're going to get one there, and then one there, there, and we're kind of getting it evenly or uniformly distributed around the whole table. That's what we want. Okay, and before we present a couple of hash functions, we usually hash functions assume integer input. So what if we have a string? So suppose we have a string am, and we want to get a hash for that. We want to feed that into a hash function. Well, A in ASCII is 65, and M is ASCII number 77, ASCII code 77. What we can do is we can express this as a radix 128 integer. There are 128 values in the ASCII table, so we use radix 128 integer. What does that mean? What it means is we're going to take A, which is 65, and we're going to multiply it by 128. And then we're going to add on the 77 and get 8397. Okay, what if we have a 3-letter word? So A is 65, C is 67, E is 69. Then we'll take the A, 65, we'll multiply that by 128 squared. Then 67 times 128, and then plus 69, and that's going to equal 1,073,605. Now, if we have a word, I don't know, that's kind of wordy, and it's not even all that long, you can see that you're going to get whatever the ASCII value of W is times 128 to the 1, 2, 3 to the 4th plus 0 or O times 128 to the 3rd, and so on. And so we're going to get a very big number, but that's something we just have to deal with. Okay, so input into a hash function is an integer. So let's look at some hash functions. The first is the division method. And this hash function looks like this. The hash of k is simply k mod m, where m is the size of the array. So for example, suppose the size of our array is 12, and let's let k equal to, say, 100. Then the hash of 100, of the key 100, well, k is the key. So the hash of 100 is equal to 100 mod 12, modulo 12, which is equal to 4. And so with the division method, we don't want m to be a power of 2. And a prime number far from a power of 2 is good. The second and final hash method we'll talk about is the multiplication method. So let's let a number a be in the range, open range, 0 to 1. Or in other words, 0 is less than a is less than 1. So a is like 0.5, 0.7, 5, whatever. Now, I won't give you the hash function yet, but suppose a is 1/2. And the key is 11 that we're going to hash. Let's look at Ka. K times A is 11 times 0.5, which is equal to 5.5. Now, if we look at Ka minus the floor of Ka, what is that? Well, Ka is 5.5 minus the floor of 5.5, which is equal to 5.5 minus 5, which is equal to 0.5. What this right here does is it extracts the fractional part. So for example, if Ka is 32.8, then Ka minus the floor of Ka would be 32. No, sorry, not 32. Strike that. It's going to be 0.8. It's going to be this piece right here. So the cool fact is that Ka minus the floor of Ka is greater than 0 and less than 1. And therefore, what we can do is we can define our hash function to be m times Ka minus the floor of Ka. And so it's going to extract some fractional part of m and then take the floor, and that will be our index into the array. And that's the multiplication method.